Hello, everyone, and thank you again for joining today's webinar, New Techniques for Achieving Social Distancing on the Plant Floor. Please note that you have joined as an audience member and are muted. My name is Madeline, and I'm today's moderator, and I'm joined by Curtis, our Director of Technology and official brand ambassador, as well as Dan, our application engineer, who will be joining us at the end for questions. So let's get started with a quick overview of our agenda. We'll begin with a little bit about Geometric Solutions, who we are, and how we can help you. Then we'll jump into our main topic, the new normal of manufacturing, specifically adhering to social distancing guidelines on the plant floor. Our presenter today is Curtis, Director of Technology at Geometric Solutions. Curtis has more than 30 years of experience in manufacturing technology and has been at the forefront of digital simulation, specifically related to virtual prototyping and dimensional quality. He is recognized internationally as an expert in digital simulation using 3D tolerance analysis simulation tools. He has experience using all the major CADs, PDMs, CAE systems, and multiple digital simulation applications. And as you will see, Curtis enjoys the blending of new technology, software, and best-in-class processes, all while driving the need for quality, resulting in the reduction of overall costs. Now, for a quick intro into who we are at Geometric Solutions, the Waltonen family is made up of 3 companies located throughout the Midwest: Waltonen Engineering, Independence Tooling, and Geometric Solutions. And our story is pretty simple. Waltonen develops innovative engineering solutions using Siemens software, and we got so good at it, Geometric Solutions started selling the same potential for success in the form of Siemens software. So when it comes to implementing and optimizing these solutions like an expert, Geometric Solutions can get you there. And no one really said it better than our president, Lloyd Brown, that our ability to successfully partner with our customers comes from our experience using the tools we sell every day. Now I'm going to go ahead and turn things over to Curtis. Curtis, take it away.
Hey, Madeline. Thanks for the introduction. And I'm going to turn my camera off on myself to make sure the video is clean. And let's go forward. Alrighty here. So today's topic is social distancing and making sure our plant is safe for everybody to participate and work well. So let's just talk about this a bit. McKinsey & Company had a write-up here, and they basically came to 3 areas of focus to transition to the new normal or the next normal post COVID-19. Protecting the workforce. We want to make sure they're safe, and that the risks are very low. Manage risk to ensure business continuity. Anticipate changes and model the way a plant should react well ahead of fluctuations to enable rapid fact-based solutions, instead of guessing how to solve it. We got some some good solid engineering thought into why we're changing things. And then, a lot of times we're driving this productivity at a distance. Not everybody's going to be in the plant that used to be. There's going to be teams that'll be, remote working, and still we got to make sure these remote working people, can see what's going on and participate and collaborate with the teams that are in the plant. So these 3 areas, we're going to talk about these 3 and how, we could do this. But first, I got a poll question here. Are your plants and facilities ready for people coming back to work after COVID-19?
And it looks like our top answer was, in some areas, added fencing and break tables.
So, a lot of folks aren't ready. Some companies are trying to get ready, but a lot of us are in the same boat. We're not sure how to do it and, what kind of tools are available, but there are some folks who haven't done anything, but, some are just done some basics, and they're not sure if it's going to work. The big thing is what you don't want to be is one of these companies. There's a lot of companies out there, it's a kind of a silly graphic here, but it explains it quite well. They're just kind of ignoring it and not taking measures to make sure everybody's safe. So what we're trying to do is make sure, you know, that your team can work safely and can collaborate when they're doing it remotely. So, you know, to talk about restarting manufacturing, you know, the challenges that are out there is really we've broken into three areas. The employee safety, you know, how are you going to protect your employees, make them feel protected. You know, sometimes that's a big thing, is just making sure they're feeling correctly, that they're taken care of. You know, how are you going to monitor interactions and make sure that if they start happening, how, you know, react to them? Make sure you can do that. And then deliver confidence to accelerate your startup in your plants, you know, because you may start up slowly, but as it goes to full production, you know, are you going to be ready for it? And then the next area is just the restarting production. You know, are you going to rearrange production floor for employee distancing? You know, are you going to add, you know, safety fences or partition people apart? Kind of like, you know, you go to the stores nowadays and they have pieces of plexiglass around the cashiers, and, you know, do those have to be put in place? And how does that affect the productivity? And, you know, and then how do you prepare for any type of future instances that are going to come up? And then, you know, making smart investments, you know, addressing COVID-19 recovery and provide future benefits. How we're going to do this? How can you get started with limited capital expenditures, you know, and utilize digital tools to further safety and production environment. So some of these investments here can address some of these things up here, and we're going to talk about all three of these areas. So with that, you know, wouldn't it be great if you could do this? And what we're seeing here is a dashboard picture of all my facilities around the world, if that's what we want to say, and, you know, where are we having flare-ups and problems. So let's watch this little video.
As an executive, you can have a view of all of your plants globally. Now with IntuSight, you can identify certain issues. For here, we're looking for social distancing violations. In this case, we see that our Chicago facility is flagged as red, noting that there is a problem. So we have the ability to go ahead and dive down into that particular facility. In this case, we can see a 2D view of that. We can turn on reports and view a report that was generated from RTLS, which is real-time location system. So within this report, we can see we had a violation at a specific location. We can see who was tagged. We can see the start and end time and the duration for each of those violations. Then based upon that, we can navigate over to the specific webcams that were associated with that violation. So with this, we can go ahead and navigate and actually view the captured incident that was flagged by RTLS. You can now review the video to try and understand why this violation occurred. Was it a poor cell design? Was it a flawed process? Or did the workers not follow proper instructions? At this point, you can virtually bring in your extended team to collaborate on improvements, design changes, or better training to resolve this issue so that it does not happen again. If you need to bring in your engineering team that is not familiar with this site, you can do so virtually. They can view the 2D layout of the Chicago site. They could view a panoramic image of the area of concern from several different vantage points, or they could even access a 3D view of the work area. This will enable your extended team that may be remote to engage in collaborative discussions to resolve plant issues quickly. Using IntuSight combined with RTLS, you can be alerted to problems quickly, track, and have a digital record of who was involved in these violations, virtually review what occurred, and enable remote collaboration to resolve plant issues, saving an enormous amount of time in getting your plant back up and running efficiently.
Okay then, so yeah, this was a kind of a, you know, cool thing. I have one site here. I can actually see live reporting across the globe, and we'll talk about how we did that. And, you know, we could see videos of the problem and everything, so the people that are working remotely can access it. So let's talk about this and this technology and how it happened. So to do this, we've come up with this, philosophy. So this video we just looked at is accomplished through this simulate, validate, iterate. We start with the digital twin to simulate the worker in the plant in his environment at the cell or at the line level, evaluating worker safety, both from an ergonomic and social distancing standpoint. If we see any potential issues, we can modify the cell layout, material flow, or even add automation to reduce the risk to the worker safety. Then we go to the validate phase, where we monitor workers in the plant using real-time location systems. And we'll talk a little bit more about that. To alert workers, when they violate social distancing and provide track and trace contact history of those interactions. Then iterate, close the loop with data and information collected in the validate stage, feeding that back to your digital twin to improve your virtual model. This is kind of a derivative of Deming's plan, do, check, act. It's a very basic philosophy of, making a plan, making sure it works, validating it, and then, act upon the changes. And so then, we just keep cycling through this simulate, validate, iterate again to gain improved worker safety and productivity. So to simulate worker traffic, to anticipate where social distancing may be hard to maintain, there's simulation tools out there. One of them is plant simulation, and we use it to identify paths with high traffic, shown in the green lines there. That's a Sankey diagram, as well as specific areas where employees find themselves less than 6 feet apart, shown as the red circles. They don't look like circles anymore because there's so many of them, but there was a series of red circles that pop up, and I'll show you that in action. We're going to simulate the impact of the modifications in the workplace or workstation design using process simulate to identify limitations posed by added safety screens, such as line of sight, or inefficiency when adding tasks to workstations to compensate for reduced number of workers or stations. We can also use plant simulate to test modifications in traffic flow management, such as adding physical screens between stations, directing traffic patterns, changing operation sequences, changing stations, and reducing and increasing workers. And then again, we can use process simulate to test alternative designs to workplaces and their workstations, ensuring workers can still perform their tasks, identify the best station design before attempting to build it on your production floor. So we're using these simulation tools to identify the problem, but also identify solutions and test them and work out the kinks in a simulation mode instead of doing it on the plant floor where it's costing time, money, and potentially some safety risk. So if we start to go into the simulate mode, you simulate your production line virtually, taking into account all the changes that are inevitable, starting with the social distancing and employee safety related modifications, available labor, specific skills, fluctuations or high growth in demand, and disruptions in your supply chain. Virtually understand the financial impact of each in the form of throughput, and come up with mitigating scenarios that test those scenarios with plant simulation to arrive at your best plan. So you know what to do in each situation. Know what it means to have 2 shifts instead of 3. Understand the impact of staggering entrances to the plant or break times. Address missing skill sets due to maintaining shifts encapsulated. Compensate for shutting down every other workstation in order to maintain a distance greater than 6 feet apart between stations. In short, run what-if scenarios and arrive at the best solution way before you face the situation on the floor. If the situation was not anticipated, use the simulation to address it much quicker. So now we're moving into the validate portion of it. And want to provide your workers, supervisors, and all the way up to your corporation management chain, or corporate management chain again, speak here, with the peace of mind that comes with the knowledge your workers will be immediately alerted should they accidentally cross the 6-foot social distancing space. Complying with regulations designed to address the risk of infections, in addition to the immediate measure of employee safety.
validate true traffic patterns and maintenance of social distancing, and identify exact locations on your production floor where violations were not anticipated but are occurring. Use the location information to direct staff to investigate and disinfect for quarantine as needed, eliminating broader mitigation that would have otherwise been needed. You know, what we're doing here is we're going to have people wear transponders, have antennas basically all around the facility, and through that we can triangulate people's locations and where they are in the facility. And once I have that information, do algorithms to figure out if they violate those standards of 6 foot or less. And should it be needed, you know, track and trace contact history. You know, identify those who have been in proximity by crossing specific tag IDs with your HR department stored and manage identification of the workers that might be at risk. If I find one worker has COVID-19, I can see who they contacted and who those people contacted and trace that through the facility. Because this is a real-time locating system, RTLS. Right? Track movements of critical equipment or raw materials to further get real-time picture of how your material flows. So I don't have to do it just on the people, I can actually do it on the equipment too. So here, I can add trusted traceability. I know if this first person violated that 6 foot area and who they came in contact with, and I can actually track it all the way down to everybody who's been involved with interactions directly or indirectly to that person. And I can actually make sure, you know, I address it if there's any issues that come up. All right, so now we're going to talk about the iterate, close the loop with iterating on the data and information collected in the validate stage, whether it's actual traffic flow, material flow, or other production parameters that might change in the first few months due to everyone in the world returning, including supply chains, demands, labor, and economic as a whole stabilize. Right? Continue and simulate, taking into account those new parameters and adjusting your production plans, investments, and workforce to maintain profitability and drive growth. Continue to use your investment in digitalization to come ahead of your competition and stay ahead. As you are returning to work and starting the cycle of simulate, validate, iterate, not all workers, engineers, managers, suppliers, or customers will be able to visit your production site, at least not until all regulations are rescinded. Continue to collaborate on critical production information across the value chain using IntoSite. Allow your remote teams to continue to work as if they were on site, navigating for information just like they would find in a restaurant in a familiar or new town. Jumpstart your simulate, validate, iterate from day one by setting up the IntoSite collaboration platform for immediate start on communication between a multitude of people that will contribute to your restart production. As production stabilizes, continue to leverage IntoSite for new product introduction planning, maturity events, standardizing on best practices between production sites, accessing production information much more efficiently, and allowing you to react faster. You know, this IntoSite gives you a window into the plant. I can see what's going on. If I know from the real-time sensors that have had violations and where they are for proximity, you know, you saw that video. I could see webcams of what was happening and when it was happening, and see the event, and then I can actually go into IntoSite and get the 3D data and see it and touch it in a CAD environment and launch that and work on it. So, you know, it's a nice wrapper around everything to allow all these tools to come together. So, embracing Industry 4.0 to maintain operational excellence through digitalization, Electrolux has done that. You know, they've done this across 53 production sites and producing 60 million products a year. You know, they make all types of appliances, dishwashers, refrigerators, and such. They use Siemens products for designing their factories and these simulation tools that I was just talking about to simulate their plant. So they use process simulate, plant simulate on this digital factory foundation and performing production processes virtually and solving issues before commissioning real production. They figure they save $2 million in savings in buffer space, alone, because they've optimized how much buffer space they need. They figure they are enjoying up to 20% lower cost on goods sold and getting products to market up to 30% faster by simulating and streamlining global productions using their digital factory. So, and kind of in summary here, there's deep challenges lie ahead for everyone as we adopt to the new normal. Companies, large and small, will need to ensure safety of all employees while maintaining production output. Simulation, validation, and iteration will model and virtualize your production floor to ensure compliance with new regulations while optimizing output. Siemens solutions are mature, industry proven, and are in production use with many large and small companies across the globe. Siemens and Geometric Solutions are committed to helping you get back to work as fast as possible. And, right now, Siemens has some special pricing on some of these tools. And actually some rapid deployment services are available to ease your transition and strain on resources. And, we understand these are difficult times. You may not have the resources and expertise necessary to get you through this. We're here to help. So let's talk about some of these simulation tools a little more in depth. Plant simulation tool at its foundation, it allows you to emulate workers in production and logistic environments, supporting machine processes, maintenance, failure, removal of parts, carrying parts, things that workers do every day. Workers are integrated in shift models, and I can have different shifts. I can actually have different classes of workers, like mechanics that can work on parts that are certified to do it, where other people are not certified to work on certain machines or parts. So we can actually model your plant just like they are in real life. Then what we can do is use this plant simulation tool, in classic sense here, I'm actually optimizing it. So here I have 10 identical stations, and we're testing what if scenarios. And if I'm going to run the simulation, I got 2 workers in there, and I'm testing how many parts they're doing and how fast they can get parts out the door and how utilized they are. Right now, I can see the people here are basically utilized 50, 60% of the time. But I can do a what if scenario and just change sequences of orders and how things are going and how the cobot that's in there or that's working with them does work. And you can see now I'm getting their usage up higher, so making them more productive. So I can test all this stuff in this virtual simulation environment and prove that it works. And here I can actually see all 10 of these stations here that I'm making these parts and the volume throughput from it. Let's say you have an existing plant that you really don't have all the design on the floor and you want to test it, and it's something you purchased, as a merger. I can actually scan that plant and put my plant simulation model in the middle of it. Here's that same model put in there where I got these workers at the stations with those cobots, and I can actually see them working and how it's all working together in this environment. So I don't have to have all the CAD. I can actually just scan a plant and actually do that. So we're not limited to having all that technology available today. We can simply get it by scanning plants. How it affects social distancing, I can calculate the distances between workers. The goal is to make sure that you're 6 feet apart, and I can actually count how many times it violates that. So let's see this in action. So here I happen to have a plant that has a couple of cells, and we just want to go through the simulation model where we're trying to test for social distancing. What we have here, and I'm going to play this a little slow here, but you're going to actually see people working in stations. They're going to transfer parts to the next station. And the red circles are 3-foot diameter circles. Whenever 2 of them intersect, a red dot shows up, and we get a distance violation count here.
So what we wanted to do was take this existing line, and the proposal was to add these fences to promote social distancing. It helps, but at the same time, we do violate that 6-foot rule with this simulation. So this needs a little more consideration. So what's great about this tool is I can test this out, I can propose alternatives, and make sure that we don't violate this. What I'm gonna do is speed this up a little bit. And actually, let's see, we're at 10 minutes. Let's run it for an hour. And you can see in this hour's time frame, we have, let's see, 60 seconds here, 38 violations. And you can see it's all over the center area. So it's not just in one spot. These people are crisscrossing past each other. So, you know, it's something that we want to review. And in today's climate of getting people back to work on the floor, you know, we may have to rearrange the fences. We may have to modify workflow paths, you know, but at least we can analyze it and prove out if our concept's going to work before we put people in danger on the floor. Okay, you can see we've moved on to a newer application here. This is a little larger line. What I have here are workstations, and you can see there's placeholders for the operators to work at the station. There's 10 stations. I have a pool of workers here that come from this break room. It looks more like a transporter here from Star Trek. But what I'm going to do here is slow this down a bit, and you'll actually see when the first part shows up here, an operator comes out to the station. They can actually work on it, and then they start filling in the stations as they go around. Real quickly here, we'll have six of them in there. That's 4, 5, and 6. And once I have the 6th worker in there, when the first job comes over here, one of these workers is going to transport, or should I say transport, travel to that location and start filling that up. And you can see we're having some overlaps here just because of the way people are rounding corners. You know, our test application here where we put these safety fences in actually starts narrowing the area of walking that folks can walk through to get from one station to another. So maybe this is not the best application of how we want to put the fencing. Maybe there's, you know, some other paths that we want to try, but that's what's nice about this tool. I can test it out and see what's going to happen. I'm going to speed this up a little bit. And, you know, you can see here, this whole center area is becoming hotspots. I mean, here we are, we're an hour and 40 minutes into it, and we already have 90 violations. So let's see, just catch us here at the 2-hour mark. There it is, 2 hours, 190. So, I mean, we're getting, you know, quite a few violations happening every hour. Back, if I look at the throughput, there's 40 delivered devices and 138 failures. So it's, you know, better than 3 to 1. So for every part made, I have potentially 3 distance violations that we're trying to do. So, you know, I can test this out through use plant simulation. I can put different applications for fencing. One of the great things about plant simulation, my worker path, you know, when they start working, and I'm just going to slow this really down. Let's go maybe 5 times speed. You can see the operator actually walks out to the station, and because this obstacle's in the way, he actually walks around it. So I just tell the operator he has to go to this station or whichever station is calling him, and the software actually figures out the path to get there. So in this case, I have a physical obstacle. They have to go around the obstacle to get it. So I can keep putting fences in here and testing it multiple ways and see what's the best way to lay that out to make sure my team is safe when I start putting them back to work, and make sure we have a healthy team and a happy team.
One last thing I'm going to mention here is you can see the number of workers is 6. I can actually play with that number and make it go up or down. I mean, right now, the original before COVID-19, it was a 6-worker plant or line. If I put 10 in there, I don't have anybody moving. It solves my problem, but now I have a lot more costs involved. Maybe what I do is they say, I have 2 workers to take care of these 4 seats, 2 workers for these 2, and 2 workers for 2 workers for these, and 2 workers for these. And that way they're just moving around each other, and then, you know, they can make that dance a little better, and they're not walking from this station over to that station and back to this station. You know, this area here, they're just tied together, and maybe I can put some barriers, and I go to the right path and I go to the left path, and maybe make that work, but we can test all that. And that's the nice thing about this tool is I can do all the testing I want in here and prove it out before I try to put it on the plant floor. So that was plant simulation. Plant simulation is around logistics and distancing, but we have this process simulate human tool, and I can actually evaluate, if I wanted to replace a person with a robot, how does that work? What value do I get to it? Here I can actually get more detail on the human. I just did a reach study. That's what those cylinders that you saw there. I can make sure they can reach the items and not, have any back issues. I can put small people in, large people in, and test them both to see if there's any issues. I'm quite tall. I'm 6'4". Low tables bother me. If every day I've had to bend down to get to a low table, that would be painful. So here I'm going to do an ergonomic test on the one on the right here, and every time I have an ergo problem or a potential for a problem, her shirt's going to change color. So you can see she's going out for that reach. That reach might be minor, but if you did that every day, day in, day out, over a month or two, there might be an issue. Holding that screwdriver up, that far away with that much weight to it, could be a problem depending on who the person is. Somebody my size might not be a problem, but somebody on the smaller end of the scale, it might be an issue. So we can test all of those things and make sure everybody's safe ergonomically and, to meet the social distancing rules that are coming into place. So here's an example. Pre-COVID-19, I got 3 operators working at a station. This is process simulate human. And they're going through their process of assembling parts and taking them to this table behind them. They're right next to each other, this workstation, and I can already see now we're going to have an issue because of the 6 foot rule. So, but we can physically test that. So what we want to do is now put these bubbles around their heads. So it's a 6 foot diameter bubble, 3 foot on each side. And if 2 of these bubbles touch, it turns red. So it's kind of nice. I can actually see real time in the simulation, whether or not people are violating that distance. And you can see when she moves out of the middle, everything's fine until they start meeting together on the other side. So, we have problems. So we can address these things and make sure they're not problems anymore. So, but we know this is a problem. Now we got to figure out a way to solve it. And that's what's great about this tool. You do what if and help solve it. So I have here another model that was already built, prep, ready to go. And in this case, we've already done some things. Everybody's wearing masks now. And I've actually set up some plexiglass shields around the workers so they're not, directly in contact with each other. They won't be working and walking back to that station. They're going to be handing their work off through the slot underneath the plexiglass there to the gentleman with the cart. So he'll be able to go up and grab that when it's ready, put it on his cart. Nobody is violating the 6 foot rules right now. It is extra labor. I have an extra person working, but depending on what's happening with how quickly they're making parts, this may even be faster because instead of spending all that time walking and unloading, they might be making more assemblies. So, but all this can be tested in this environment, and I can actually prove out that yes, this works for COVID-19, and maybe I get a production bump too for the value. Yes, I have an extra worker, but do I get that much more output through the system? I can even do it here at home. People here recently over the past few months have done, the home office thing. A lot of people have done this. Some people still are doing this, right? So how do you set up a home office and make sure it's comfortable and ergonomically good? A tool like this can be used for that, right? So here I'm actually going to pick a couple of rules here for quality and safety and how repetitive things are going to potentially hurt you. So, we can just do some tests here, and you can see her shirt's turning yellow. It's not a bad risk, but it could be over time a risk. So we want to keep these scores as low as possible So, you know, we want to adjust the seat to keep the wrist up and, you know, straight instead of being tilted. So I raised your seat here, and you can see my codes went from 4 down to 2 right at the get-go. You know, I can make sure everything's reachable. I can make sure, you know, the monitors are at eye level, right? So I can actually get into posturing here and make sure that, you know, everything's, you know, I want the monitor an arm length away. So, you know, that's a good place to put it. So I can take that monitor, move it back. But, you know, this is a simple at-home type application, but this could be done for every workstation that a person is working at on your plant floor. You know, we can make sure it's very robust for them, that they can get to everything, they can reach everything. So these happen to be arm swings. I want to make sure that I can get to my mouse, my keyboard, and very importantly, my coffee. You know, can't go the day without your go-go juice. And you know, it's, you know, makes it very robust to make sure everybody can productively work, safely work, and become and are comfortable doing it. You know, there won't be any type of long-term stress issues that show up. You know, and the goal here is your corporation, you know, you want to win. You want to make sure that you are, you know, going to come out of this COVID-19 and this new normal a winner. But to do that, you got to talk about a plan for winning. And that's what we're trying to talk about today. So I showed you some of the simulation tools. Now I want to talk about this real-time locating system, right? So I showed you that video in the beginning, and it was kind of cool. And they were talking about violations and everything. And the way that was done was through this real-time locating system. So I talked earlier about employee safety, restarting production, making smart investments, and some of the, you know, things, the challenges we want to do. And I want to talk about each one of these real quickly. But before we do, what I want to do is talk about this real-time locating system. Right? So there's going to be these gateways. They're basically antennas. The antenna is going to be throughout your facility. Each employee would wear one of these smart transponders, right? Battery powered, and as they walk around during the day, the multiple gateways here will triangulate their location, and we're within 6 inches to a foot of the actual space they are on their plant floor. So with that, I can take that information and it goes, you know, to a database here where I can actually do some analysis of it. And once I have that, I can basically, every time there's a violation, I see where it is. I know where it is on the plant floor. I know who was involved in it, and, you know, on the timestamps of when it happened. If I find out it's always happening at break time because everybody's funneling to go take their break or run into the restroom, well, that's an issue. And maybe I have to readdress how that's done. Maybe I stagger break times. Maybe I, you know, change how the restroom, you know, entrance is managed. If it's 80% of the time when somebody's at their normal workstation, that's a different issue. I got to solve that. But I'll know this. I'm not guessing. I'm not assuming everybody is good. I got real data that tells me this. In addition, I can take these transponders and actually put on my work material and do this with my work material through the facility. But, you know, the cool thing about it is scalable. I showed you in that original video where I had a map of the globe, and every one of my plants have these. And I can actually see what's going on in every plant and where the violations are and what's going on. As a dashboard, I can actually make sure as corporate management that I'm making sure that these issues are being addressed, tracked, and eliminated. So again, we have these three categories. I'm going to start talking about employee safety. You know, the solution here for that is they'll have these wearable RTLS transponders, and, you know, it knows where I am, and it basically makes sure I'm doing safe social distancing. If I'm not, it'll let you know. I can actually have the thing beep, and, you know, the transponder beep at you. But then again, also, I'll know that and track it so I can monitor it and fix it. Creates a history of employee movement, so I know where they are. That way, if an employee becomes sick that day, I know who they've interacted with and who those people have interacted with, you know, and, you know, it can be reviewed and action taken, you know. So it helps to minimize virus transmission. That's what we're trying to do here, is to, if somebody was sick, we can actually track down who those people are and make sure they're taken care of. When we start talking about restarting production, this allows employees' movements to be analyzed and optimized. Maybe we have to change workflows inside a plant and how people move, and we need to understand that. That at a single employee at a workstation, that their training can be verified. Maybe there's training steps that we want to make sure that they can do to make sure they're safe. And lastly, we monitor movement of shift changes and optimize transitions. When you have a bunch of people entering and exiting the plants, you've got bottlenecks called, doors and gates to get into the plant. You have people coming in and going out. How do you make sure everybody's safe? This can help do that. And then smart investments, when between all these tools, it's not if you want to use these tools, there's some work to it. If you have the tools already, you still got to apply the manpower to it. If you don't have the tools, you got to apply the tools and then have the manpower, right? So the infrastructure can be used to task other things when this social distancing is no longer required. So I can use this for more than just this initial need. Siemens Finance offers financing to change it from capital expenditures to operational expenditures, which is kind of nice. Because if you have a capital expenditure cap where you can't spend it, but you have operational money, we can use, creative ways to get that to work. And then, we're using tools as the product digital twin, can utilize this data to optimize the processes and safety. So now that I have this data, I can actually put it in the digital twin and find out what's going on and fix it. So can these tools help you restart manufacturing?
Looks like our top answer is yes, we really need help.
Yeah, not many folks are, have it all in the bag. I mean, I'm in this business, and we're coming back to work, and we're still fighting with it too, because it's not, we're not completely up to speed on where we'd like it to be. So it's good, it's good to feel to recognize that. So, the whole thing here is, we want to talk about, the whole idea we're trying to present here is mitigating the risk of spreading COVID-19. There's tools out there that'll help you do that, manage it, and make sure your employees are safe. And that's what we really want to try to do. So with that, our goal here is to make sure you understand that COVID-19 is a big thing. The new normal is going to be different, and your employees are way too valuable to gamble with on safety and well-being. So with that said, are there any questions out there?
Hey, Curtis, nice job on that presentation. I especially liked where she went and grabbed a cup of coffee. I thought that was cool because that's realistic.
Yeah, that's, as you can tell, as I was going through this, I have my own cup. Yep, my special.
Yeah, me too.
Special cup.
No, that was nice. So the question is, or one of the questions, the 6-foot circle and then the 6-foot sphere that we saw, how long does it take to set up those types of models?
Oh, what? The 6-foot circle and all that stuff, that portion of the model is really easy. It's just setting up the rest of the model, the environment. So if I'm doing that small cell where I had the 3 people with the spheres around their head, that's probably a day's worth of work. Not that hard for that one cell. The plant cell that actually, the one that was quite large that had the 10 working stations, that was actually developed for a respirator that was done during the pandemic here. And that cell was probably about 2.5 days. But a lot of that time was making sure we understood the timing of everything. Because each station, how long did it take to put those 5 parts together they were putting together, and how long was the operator needed to be at that station? So that was the hardest part to do. But it's not large, super, big investments of time. It's pretty quick, and once I have that done, putting that quick little variable on there with the cone, or the sphere, or the The cylinder around them is real easy.
Okay,
If anybody
If
does,
you-
we have the code and I can just hand it off.
gotcha. What if you don't have a model of your plant? If you just have a 2D DXF layout?
Well, that's phenomenal. If you have the 2D drawing, I mean, I've even done this on what I'm going to call the barroom napkin sketch, you know, because we just take a sketch, draw it up, and we use that for placement, and we kind of draw it as close as we can to scale. But if you have an AutoCAD drawing or some flat drawing, I can actually import that in underneath my model. And that way I know where everything's placed and I can create the thing on top. There's drag and drop widgets to emulate conveyors and workstations. And you just drop them in and kind of scale them to size, because it's more that the walking distance and the fencing is the right size than the CNC that's on that station is the exact same color and size as the manufacturer you got. You know, you just need a box there to show that parts are going in and operators working with it and leaving away. So those things can be done really quickly and easily.
Good. And then what about this as a service?
Well, this can be done as a service. One of the great things about our group of companies, this Waltonian family of companies, is I'm sitting in a building right now where I have 200 workstations sitting out in front of me with engineers. I was going to say I got 200 engineers, but I really got 100 because they're spacing them apart now. You know, we're not all sitting next to each other anymore. So, but we have the engineers and designers that use these tools every day. So if somebody wants it as a service, we can just do it as a service to help you out. And if you think it's worthwhile, you can actually buy the software or buy the tools and deploy them. But right now, you know, if you're looking at just something to help you mitigate a certain problem, we can help you do the service and be done with it. Or we can sell you the software and the training and help you do it yourself.